This is the first of two videos that I'm going to put on Blackboard for the class examples 3.4. This one will be just for the first tab for skid marks. So let's see if we can get through that information. What I'd like for you to do is, just like in class, I'm going to illustrate a piece, and then I'm going to wait while you stop the video, practice it on Excel for yourself, and then you come back and start the video again so that you can practice as we go, just like we would have done in a classroom situation. So let's look at this first example, where we have the skid marks used. The policeman would measure a skid mark to predict the speed of the car, which we've talked about in another example we did earlier in class. And we want to find the average rate of change from 10 feet to 80 feet, which will be just like we've calculated before. Average rate of change would be like slope. Average rate of change from 10 feet to 80 feet. And we'll do a slope calculation using the y values that's listed in the table for 80 and 10, and the x values of 80 and 10, and use our slope calculation equals y2 minus y1, don't forget the parentheses, divided by 80 minus 10, to get a value of 0.46. And of course we want to get the units on that, and that's miles per hour per feet, using the units from the y's and the x's that are listed in the table. So you should stop the video and practice that on your Excel and see that if you can get 0.46. If you don't get that, you can always come back and rewind the video, or you can look at the class examples answer key and see how I've posted that and the answers in there. Click on the cell to see what values we just typed in to get the 0.46. To do part B, to find the average rate of change from 20 feet this time to 50 feet, do a similar calculation, except this time using 50 and 20. So 50 minus 20 for the speed, and then the x values for 50 minus 20. And we get a slight different answer, the miles per hour per feet. So stop the video and make sure you can get that value. And then checking our answers on the class example answer key, notice that we've calculated those values, and you can always click on the cell to see what is in that cell. And then here we've reminded ourselves of what the interpretation is from the average rate of change. So the speed of the car was traveling, goes up by 0.46 miles per hour for each additional foot of skid mark. So as they're measuring, each additional foot will mean that the car was traveling a little bit faster, which of course we knew made sense. Now you can tell a slight difference in the answer for the 20 to 50 than there was from the 10 to 80. Now this text box over on this side reminds us that those are the questions. If you can answer questions A and B, you're going to be fine for what you need to be able to answer and do for test 1. Those are the types of questions we will use for learning objectives in test 1. However, it lends itself to carry on to the next two questions, or especially to question D, that helps us look at something that will not be on test 1 but will be on later tests. And so that's why we want to go ahead and expose you to it now while we're talking about average rate of change. So going back to the class examples that we're doing here, question C asks us to fit a power trend line. So of course we're going to get our data, insert a scatter plot, and put our titles in. And labels for each axis. And fit a trend line. So we'll do a right click, add a trend line, power. See that we have a really good fit for the power trend line. I can see that it's not only got a good R squared, I can see that the trend is the same, the end behavior looks the same, many of the data points are all in line with this trend line, so I'm feeling really good about the prediction that this trend line is going to give us for this table of data. So stop the video, make sure that you can get that trend line before we continue. The next thing we're going to do is just to see how close we are in predicted values. It doesn't ask us to get this predicted row, but I wanted to do it just to make me feel better about, see how close the values are. So predicted using the power trend line. Of course, we'll enter that data, 5.4965 times x, and raise that x to the 0.5017. And get all the predicted values for the row. And I'm pleased with the values, how close they are. I can tell that these predictions are good predictions for, makes me feel pretty confident about what it will predict for values that are not on the table. So then that's the part we're going to use to get this estimate the instantaneous rate of change. So the question is, what if we got it exactly, if we want to find out what the instantaneous rate of change is at exactly 40 feet, instead of between, here we did between 10 and 80, and between 20 and 50, what if we wanted to find out the rate of change at exactly 40 feet? How fast is the speed changing at 40 feet? Not how fast the speed is at 40 feet, because we can see that's 35.1 miles per hour. We want to know how fast is the speed changing at 40. And to do that, I'm going to show you the table that's already created in the answer key so that you can see what's happening. Notice that to do that, we're going to create a table with values very close to 40. Here's my value of 40. Notice on the left side we're getting closer and closer from the left of 40, and here we're getting closer and closer from the right of 40. And let's see if we can create that same table for ourselves. So you can stop the video and create your table that's going to go up close to 40. 39.999. I did that backwards. And then 40 in the middle. Check those values and get your table set up. And then we're going to use the predicted values from the power trend line, which is why we wanted to get that trend line. So again, 5.4965 times x raised to the 0.5017. We know those values are good and close. But this time we're going to actually do a little bit different for average rate of change. We're going to actually find the average rate of change between 39.9 and 40. But then the next one I want to do between 39.99 and 40. And the next one between 39.999 and 40. I want to calculate the average rate of change between each of those pairs, but each time the 40 is in it. So if I want to do that, I'm going to do a slight different average rate of change formula. So we'll do y2 minus y1 divided by x2 minus x1. But this time, because I want, for the rest of them, I want to use 40 again. Rather than retype it in every row, I'm going to let Excel help me out. So I want this blue and purple cell to be used every time. So to do that, go back over to hover over and click in the cell. I'm right in between the F and the 25 in this case, and push F4, which is on the very top row of your keyboard. If you don't have a F4 button, some Macs do not, then you can type in the dollar signs here instead of clicking the F4. And the next one I want to do is the purple one, because I want to use this 40 every time. Go hover there, click in that cell, and F4 again, and it creates the dollar signs. I should have known better, right? F4. And you can see I've got the dollar signs on the blue cell, dollar signs on the purple cell, but not on the green cell and the dark red cell. So it's calculated the average rate of change for me, and I'll pull that across. So as I double click in this cell, notice that it left the blue and the purple cell the same, but it changed so it left y2 and x2 the same, but changed y1 and x1. Same thing here. It left y2 and x2 the same, changed y1 and x1, and it does the same thing on the right hand side. And what we can do is see what happens as you come this way. Notice the numbers are getting closer and closer to 0.438. Maybe it would round off to 0.4388. And here, closer and closer to 0.43, again, 0.4388. So that's how we were able to draw the conclusion that at 40, we're going to notice that the instantaneous rate of change, that's the rate of change at that one instant, is 0.4388 miles per hour per feet. So that's where we came up with the instantaneous rate of change that we're looking at. This type of question is not on test 1, but it is something that we wanted to help you get ready for future information that we're going to cover involving limits and instantaneous rate of change. That's all we need to do for sheet 1, and I'll stop this video and then we'll start the next one. I'll start the next video on sheet 2 on rate of change.